Okay, can we start now?
Yes.
Yes, Kapil.
Right. So this is where we stopped. Are we all here? How many of are here? 17. So 1 or 2 more to come. That's okay. We'll slowly start. Right. So this is where we stopped. Right. They generate machine hours and labor hours both. Machine hours, they will generate altogether 45,000 machine hours here. And labor hours, in the machining department, we generate 52,500 labor hours, and assembly department will be generating another 52,500 labor hours. That's where we stand. Now, can you tell me what was the first method that we discussed? What was the first method that they discussed which you used to share the overheads? So even for the, based on the question, okay, let's go through the question. First is that plant-wide overhead rate. Estimate the unit cost of valve A and valve B using single plant-wide overhead rate. Okay, before that, okay, there the first requirement is set based on the direct labor hours. But even without that, let's try to share the overheads equally into all the products, right? We are not going to differentiate assuming that they are homogeneous product. We are going to share them equally into both the products, right? So then when you want to share it, okay, so this is where we are going to share it. So how much is the total overhead in the factory?
900.
Total overhead in the factory, how much is that?
945,000.
945,000.
945,000.
Hello? Sorry, hello, can you hear me?
We can hear you, Kapil.
You can
Sorry, you could hear me earlier, right? The volume was low, I suppose.
We could hear.
Right.
No, we could hear.
No, we could hear. We could hear. I
right,
don't think
okay.
you heard. Okay, right.
Yeah, I didn't hear what you said. That's the thing. Right, okay,
Yeah, okay.
right, okay. Right, so how much is the total overhead?
945,000.
945,000. And how many units do we make altogether?
35,000.
35,000.
30,000 of valve A and 5,000 of valve B. So altogether 35,000. So which means our unit rate will be, if we share overheads equally, 945,000 divided by 35,000, it is $27 per unit. Okay. So which means if I want to do a costing of my product, this worksheet, absorption template, you can go there, absorption template. And how much is our prime cost?
200.
200. How do you get this?
That's the
Direct labor and
material
direct,
plus direct
material.
labor.
Direct material, direct labor, 140 plus 60, 200. So this is what we get, right? And then overhead rate will be per unit rate. So the per unit rate is 27. And then each unit, so which means valve A also you will get $27 per unit, and valve B also will get a $27 per unit. So altogether it will be $227 and $227, because we are not differentiating by product. We are trying to share the products equally, treating them equally. So therefore both products will get the same cost per unit and overhead per unit. And then since the prime cost is also the same, we'll be ending up with same overhead per unit, same total cost per unit. There is no differentiation. Okay, now what is the negativity of this? Anything that you feel, that you think which is not fair here?
The complexity of producing each, I mean, different types are ignored.
Yeah, complexities and the complexity of the activities involved in producing each product is also ignored. At the same time, the fact that they consume different amount of resources is also ignored. It is not going to be considered. And then probably, another aspect that you can try is the second method. We've been asked to calculate using plant-wide overhead rate. What we discussed earlier. Estimate, I'm referring to the question now, estimate the unit cost of valve A and valve B using a single plant-wide overhead rate based on the direct labor hours. Single plant-wide rate based on the direct labor hours. So how do we do that? So if we have to establish a plant-wide rate, so then we should know the entire plant, how much is the overhead, and entire plant, how much is the direct labor hours. How much is that? Overhead is how much?
945,000.
945. That doesn't change. And how many direct labor hours do we have?
45,000. Oh, sorry. Direct labor hours is 105,000. 105,000.
Exactly. 105,000. So here nothing is considered, whether it is machining department, assembly department, we are not bothered. We are going to put everything together and we are going to have one single parameter. So we will be using 105,000 in the labor hour, right? So which means we have a labor hour rate of 9 per hour, right? So which means in this plan, we assume that labor hour generation is the primary activity. If you have to generate more and more labor hours, our cost is going to go up. On that assumption only, it is more likely that other than any other parameter, labor hours is the more likely parameter which is driving cost. So therefore, typically to generate one labor hour, it is going to cost us $9. That is a labor hour rate. Okay, so this rate is applicable to the entire plant. You are not differentiating by the department or any other parameter. Now we are going to calculate the overhead. So now here per unit rate base will give us a cost per unit of 227. But now the plant wide rate, we are trying to calculate how much is the total production cost. Here we have estimated, we got the prime cost anyway. Now you have to tell me, valve A, each unit, how many hours we are spending, labor hours is a labor hour rate, and what is the rate that we should use. Valve B, how many labor hours do we spend, and what is the rate that we should use. You have to tell me.
Rate is 9 for both, I believe.
Rate is 9 for both. Our overhead absorption rate is 9 for both valves. It's the same rate in the plant. How many hours?
Same, 52,500.
Now here we are going to calculate the per unit. So therefore we should get the per unit cost. How much is the per unit hours?
1575.
1 and 3 hours.
3 hours. So there is one suggestion, 3 hours. What about the others?
2.5 hours for type A and B is 4.5 hours.
Okay, now we are using a labor hour rate. Our overhead we divide by the labor hour rate. So therefore we should base the
Shouldn't you multiply the total labor hours by the per hour rate and divide by the unit numbers?
you can do it, but still now since anyway we are going to calculate it per unit, you see without using the total hours, we can use the hours per unit. So then straight away we get it per unit.
3 hours per
Yeah,
unit.
the 3 hours per
Yeah,
unit.
for both 3 hours a unit.
3 hours per unit.
Exactly. For valve A also, in assembly department, we use 1/2 labor hours. Valve machining department, we use another 1/2 labor hours. So altogether, valve A also would use 3 hours. Valve B also would use 3 hours. So altogether, valve A would absorb $27 per hour per unit. Valve B also would absorb $27 per unit. Okay. Now here, this is what we have. Right now, what you will see is just to do a reconciliation. Valve A we produce 30,000 units, and valve B we produce 5,000 units. So each one of these 30,000 units will be absorbing 30,000 into 27 will be absorbing $810,000. Each one of these will be absorbing 27 into 5,000. They will be absorbing 135,000. So altogether, when you calculate it, you will see these two products will be absorbing $940,000 of overhead. Right? So basically, when you take the two products together, they will end up in absorbing, what is this 940,000?
That's the
That's
overhead.
Total
Is it
Total estimated.
overhead.
Okay, so you end up in absorbing the entire 945 into the two products. So you can see the product that has a lower volume will end up in absorbing a lower amount proportion of overhead, and the one which has a higher volume will end up in absorbing a higher amount of overheads, right? It's purely volume driven absorption. Still, we don't see a differentiation between the cost of the individual products. That is an important observation.
Kapila, can I-
Because the labor hour consumption is the same for both products. Okay. Right. Now we go back to the next computation. What does it say? Estimate.
Kapila,
Yes.
can I?
Yeah, Riman.
Yeah, just because I did it, I got the same answer because what I did was the unit rate, because I noticed the labor hours are the same. So I just used that to arrive at the plant-wide rate. I know if the labor hours are different, it will not work. In the exam situation, will that be an issue? Because since the labor hours are the same, I just use the plant, the unit rate. We are ending up with the same answer.
That is okay, but only thing is typically you will be given to calculate labor hour rate. The labor hours are different. Here, this is the illustration purpose.
Yes,
Obviously,
yes,
so
yes.
yeah,
Understood.
yeah.
Got it.
Okay. Right. Let's go ahead. So the third one is departmental rate. So now we have been told this. What does it say? Estimate the unit cost based on the departmental overhead rates. The machining department rate is based on the machine hours, whereas the assembly department rate is based on direct labor hours. That is what we have been told. Machining department, we have machine hour rate. Assembly department, we use a labor rate. Why? Because they think that, okay, machining department is a sort of, even though there are people to support the work in the machining department, right? Most of the overheads are relating to the machine hour generation. That is the logic. So this is the process knowledge that you should have, right? That is the process knowledge that you have, so that you have an idea that basically, one moment, that if you have that process knowledge, you will know probably there are a lot of machinery. So most of this, you can see the overhead of the machining department. I think it was, how much is that? 630,000 of the machining department overhead. It is primarily probably comprising of the machine depreciation, machine insurance, machine maintenance, electricity consumption for machinery. Like that, it is more likely to vary with the machine hours. So that is why we have a machine hour rate. At the same time, we assume that out of this 315,000 cost of the labor intensive department, assembly department is actually most of it is labor related overhead. That is why we differentiate between the two rates. Now, what we will do is this. So now we are going to calculate a departmental rate. It's not the same rate. Machining department, we are going to calculate the machine hour rate, and assembly department, we are going to calculate an assembly labor hour. Okay. How much is the overhead of the machining department?
630.
630,000.
630,000. And how much is the overhead of the assembly department?
315,000.
350.
15,000. So the same overhead, right? 945,000. Now we are taking a department-based view perspective. And how many machine hours do we generate in the machining department? So we have been told specifically a machine hour rate for the machining department. So therefore, we have to use a machine hours in this, establishing this rate. How much is that? 45,000 exactly.
45,000. Yeah.
Yeah,
45,000. 45,000. So therefore,
40.
we have a 45,014 rate. So which means whether it is valve A, valve B, or even if there are so many other valves here, a machine hour generated in this machining department is costing us 14. So therefore, proportionate to the number of machine hours consumed by the product, an appropriate amount of overhead should be absorbed to the individual product. So it is 14 here per machine hour. Okay. Similarly, think carefully and tell me what is the labor hour. We are going to have a labor hour rate for the assembly department. So what is the number of labor hours we are going to use for the assembly department?
2,500.
52,500.
52,500 exactly. Labor hours in the assembly department, because the labor hours, when you do the assembly department overhead absorption, machining department labor hours are gone. It's not relevant. Machining department, you already use a machine hour rate. So the assembly department, we do have 52,500 hours. So that is the assembly department hours. So we have to share it based on that. 52,500 is the hours. So we have the rate of 6. Okay, so that is what we have. Okay, now I will give it a try. I want you to give it a try. So now we know that machining department has a machine hour rate. We use a machine hour rate in the machining department. Assembly department has a labor hour rate, which is 6. Now you go to our overhead absorption sheet. Go to our overhead absorption sheet, and can you establish the product cost? You can look at here and calculate the product cost based on these two rates. You can give it a try. Nalaka, I'm not talking. I just want you to try this. You said you can't hear. I just try this computation. If you use the departmental rate, what is going to be the per unit cost? What was the answer that you got for valve A and for valve B?
Total product cost is 223 and 253.
The other one?
251.
251, sir.
251. Okay, let's see. Now, if you take the valve A, prime cost is 200, valve B also prime cost is 200. And machining department, if we start first, machining department, we have machine hour rate. So valve A, how much of overheads are we going to absorb? How many hours? 1 hour into
14.
14. Valve B
3 hours into 14.
into 14. So machining department overhead now only $14 is absorbed to valve A, $42 is absorbed to valve B because it takes more hours, more machining time. And since the department's overheads are likely to be driven by the machining time, so you have to take higher amount of overheads to the product, which consumes higher machine hours. Assembly department, how many hours?
1.5 into 6.
Okay, 1.5 here. Valve A, valve B
Same.
is about the same, and the rate is 6.
6.
So both will be absorbing 9. Okay. So now, which tells us that, okay, valve A, total cost with absorbed overheads based on a departmental rate is going to be 9 plus 14, altogether 223 for valve A, 9 plus 42, 251 for valve B. Okay. And also we can do another reconciliation. Let us say valve A, we have 30,000 units, and valve B, we have 5,000 units. So 30,000 units into 9, 27,000 is absorbed into valve A. Something wrong.
3,000 should be 30,000.
30,000 is thanks.
I checked it. It reconciled couple.
It reconciled.
Yeah.
Right. So altogether, so when you add these two together, so this is happened to the 315,000. This is the assembly department overhead. So similarly, in this, it will be 14. Sorry, I can put the number of units. 30,000 and 5,000. So you will have 30,000 into 14, and here 5,000 into 42. So when you add the two, so you have 630,000. So 315,000. This is what happened to entire 315,000 is absorbed to the two products in the assembly department overhead, and the machining department overhead of entire 630,000 is also absorbed to the two products. So this is how it is going to be absorbed. Okay. Now, what is your comment about the fairness of this new cost per unit? Earlier, both were demonstrating the same amount of, displaying the same amount of cost, but now this seems to be cheaper than what we initially thought, and this seems to be a bit more expensive than what we initially thought. Do you think this is more reasonable, and what is the reason?
More reasonable because product B takes more machine hours, 3 hours, assuming that's where bulk of the cost is. I mean, that is indicative of cost being driven. I think this is more fair.
Yeah, exactly. So you can see out of the two departments, assembly department is costing us only 315,000, but machining department is costing us $630,000 to run. So which means assembly department, machining department is the expensive department. So therefore, if valve B takes more time in the more expensive department, obviously it has to be more expensive, right? So therefore, that is why this is more expensive. This is marginally cheaper, but this is really expensive. Say 227 has become 223. It's about less than 2% change, but 227 has become 251. It is almost 10%, 9 to 10% more expensive than what we initially thought. Okay, right. And now we are going to go to the next stage of our computation. They say estimate the product costing using ABC-based cost estimates. Suppose Delta's accountants have established the following activity cost pools and cost drivers in stage 1 of the ABC method. So basically now what we have been told is we have been given some information like this. What is the information that is given to us? Now earlier, here we took a departmental perspective. Machining department and the assembly department. So we took a departmental perspective. But now we don't look at departments, but we take an activity perspective. We are no longer looking at machining and assembly department. We are looking at machine setting up activity, engineering and design activity, material handling activity, quality control activity, and other machine running activity. Right? So this earlier we took a vertical view, and now we are taking a horizontal view, which is across the department. That is exactly what I was trying to show you here. Can you see a different worksheet now?
Yes.
Right. See, earlier we had the departmental rate, so machine hours or labor hours. So department-wise only, we looked at the department-wise. Department low head absorption rate, department 1, department 2, department. Because we were not focusing on the activities, we were looking at the departments this way. But now what we try to do is, yes, the departments are there, but what we feel is more than the department level, it is more likely that the costs are going to be driven based on the activities that we perform. So therefore, while the departments are being kept, we are trying to look at across the department, what are the activities that we will have to run, generate to keep this in operation. So 630 and 315 was the division here, but now it is a different division for which we have been given the detail. Okay, so again, we'll be looking at the rationale later, but do you have a basic idea of what is happening here?
Yes.
Okay, right. So now we go back to our calculation worksheet. Now we go back to our calculation worksheet. This is where we stand. Right? And now what you need to do is you have to go to your question, and we have been given this detail. First of all, we have been told that machine setting up activity cost is 6,000. Machine setting up activity cost is 6,000. Engineering and design cost is 210,000. Material handling cost is 22,000. Right? Quality control cost is 32,000. Machining related cost is $675,000. So altogether, when you take this, this is now what has happened to 945,000. Okay. And how we do this breakdown, we are not going to take a look at now, but later on I will explain you. But basically, this is done in a simple term. This is done by talking to various people who are engaged in these activities, and we will ask them in terms of their manpower and other resources, how much of their time is spent on these different activities. So it is basically mostly interviews and other resource utilization studies only. We are going to have this breakdown, and very simple example I will probably do not in the next lecture. After the lecture after next, we'll look at a very simple example of how we do it. But later on, when you do the workshop, we'll be looking at a very comprehensive example. Okay. Now, what does it mean? We say machine setting up cost is 6,000. What does it mean? What is machine setting up?
I believe readying the machine before production run is taken, you need to set up the machine.
Exactly. This is setting up. Yeah, exactly. Because now you see, valve A we produce that. Now this is not only manufacturing, right? Any operation is applicable, but just get the logic. Like say you have valve A, we produce 30,000 units, valve B, we produce 5,000 units. But usually this entire quantity we may not be producing at once. right? What we'll do is we'll be depending on the demand and the warehousing and other logistics. So we may set up the machinery, do all the setting up of the machinery, and we may start producing valve A. And we may produce certain quantity, maybe 500 or 1000 or 2000 quantity. And then once you do that, we will stop producing valve A, and now we have to start producing valve B. So once you do that, so that means once you stop producing valve A, you have to remove and clean whatever the leftovers, and you need to probably remove the tools that are not required for valve B, fix the tools that are required for valve B, right? And then you need to do a sort of trial run, and until the process is set, and then you need to come and tell the operators and see the technical input will have to come in, and you need to come observe and ensure that the operation runs smoothly. So that is machine setting up cost, right? So once again, so during that time, we don't generate machine hours, right? So we stop machinery, we generate the machine hours, and then you stop it, clean it, reset it, and then only you start generating machine hours. So therefore, this is the cost that you are incurring, not in generating any production volume, but this is the cost of the lost time that we lose when we have a changeover. Okay, right. And secondly, what do you think the engineering and design time cost is? This is basically engineering and yeah.
Sorry, I was about to, because these are valves you need to design by engineers.
They have to be designed by the engineers, but they have already designed. So in that case, what do you think this engineering and design?
That's a cost
The
of
mold.
getting that installed.
Cost of getting that?
Installed, designed and installed.
Yeah, no, it's actually, no, this is initially, but now when you run it also, what happens is, now there may be, you need inputs, like sometimes there can be breakdowns, and sometimes you don't get the required quality, and sometimes say a particular valve, the valve is a new valve. So therefore, when you start doing it something slightly different, and then it may not come to the required quality. So then probably they will have to come, see, inspect, change the material, change the tool, and change the speed or whatever, and then they need to spend a little time, right? So then again, that is not generating any hours, that is not generating any units. But just to support that, engineering and design input will have to come in. So therefore, you identify that as a separate cost pool, right? And then material handling is obvious, right? Material handling is shifting material from one place to another place. And then we have quality control, right? What is quality control?
Is to ensure that the product meets the quality.
Yeah, okay, just to ensure. So how do you do that?
Times that you inspect it.
Okay, you inspect it, and then
sample test.
Hours.
Okay, you take the samples and you may do the sample test. Sometimes it may be testing, sometimes it will only be the labor and whatever the testing material, but sometimes it may be destructive testing. So the quantity, whatever the product that you test may be non-usable, may not be sellable. So is it related to the production volume?
It is.
Is the quality control cost related to the production volume?
Generally so, because if you take a aircraft industry, certain parts are subjected to CT scans, certain samples, because they are highly critical components, like the turbine blades and such. So they are sort of related to the volume.
Right. Okay. Okay. Is it always related to the volume when there are different products?
Not necessarily.
Sorry?
These can be semi-variable, some can be fixed irrespective of the volume.
Yeah, sometimes. Yeah, because now say, for example, your two products are for two different customers, right? And two different customers may be having two different quality standards, right? So one customer might say you need to check 10 units sample testing for every 100 units that you manufacture. Another customer might say you can do a 10 unit sample test for every 1,000 units that you manufacture, right? So then that means the frequency or the number of percentage of items that you sell, sample check may not be the same across all the products. It could vary from product to product. Or else one product, like a simpler product, the number of dimensions that you measure and all that, the testing, whatever the activity can be simple. right? Another product, the number of measurements that you can take or the testing activity can be more complicated. Again, depending on the complexity of the product, as well as which customer, which market. So therefore, it is not related to the volume, right? Similarly, engineering and design also may not be necessarily related to the volume, right? It is not necessarily related to the volume, because one product you may be having very large quantity, but it has been, say for example, which product would you think out of these two products, which product do you think which would require more engineering and design input, and which product B would require more? Why? Because it is a more complicated product which has been introduced later, right? It is nothing to do with the production volume, right? Similarly, machine setting up, what aspect will it be? What will be the driving factor? Is it the volume or something else?
Once again, complexity, because some valve B might require special tools to be fitted
Okay.
to the production.
Okay, one thing can be the complexity. What else can it be? Sometimes it can be the number of batches. Like every time you have a new batch, you need to do a setup, right? Okay, every time you do a new batch, you need to do a setup. So therefore, whether you manufacture 1000 units in a batch or 100 units in a batch, but the setting up operation can be somewhat similar, right? If it is a uniform setting up, but like you said, the setting up is also different. So then that brings in another dimension to this. Okay, the point is that. Okay, machinery related costs, what do you think?
This could vary depending on the product. I was thinking, I don't know whether this is where it goes. Like certain valves may, let's say valve B might require a more complex mold. So that cost of that mold may be included here.
Yeah, that can be there. And then also that is true. That so therefore it is machinery related. But then again, what it varies. So we need to look at what is the factor it drives. But now the point here is that we are not going to have an engineering study here. But now you have some sense to say that now we are not taking a departmental perspective, but we are trying to identify the activities within this organization, right? And now you have been told that activity cost pool, and now we have something called quantity of cost drivers, right? Now we have been told here with this 6,000 units, we do setting up of machinery. And how many setups times that we do set up machinery here? Can you tell me by looking at the question? How many setups do we do?
120.
120. We are doing 20 setups of valve A and 100 setups of valve B. So altogether, we do 120 setups for valve A and B. Now, any one of you is not clear, please ask me, right? Don't proceed with any doubts. Just we need to move with proper understanding. So you can, anytime you can stop me and ask, right? So altogether.
Could you explain it again?
Which one? Okay, now if you look at our question, we were told at the second page, I think 349, we were given a schedule. There we are told machine setting up activities costing us $6,000. With that $6,000, we make 120 setups, which means 20 setups on valve A and 100 setups for valve B. Basically, we have 20 production runs on valve A and 100 production runs on valve B. So altogether, valve A and B taken together, we have 120 setups. We have 120 machine runs, production run, on which we are spending $6,000 in setting up. Is that clear? So which means every time we set up the machinery, it is going to cost us 6,000 divided by 120, $50, right? Every time you stop the production run, you stop it, you clean it, you set up the new machine and start the new run. During that time, that setting up activity is going to cost us $50. Okay, right. And then engineering and design, what is the cost driver? So here the cost driver is setups, and cost per cost driver is 50. And engineering and design, what is the cost driver?
Hours.
Hours.
Engineering hours. How many hours?
7,000.
7,000.
7,000. So we all together we have 7,000 hours. This is what we have, right? Engineering and design 7,000 hours. And what is the, how much is the cost per cost driver?
30.
30. So we will be incurring $210,000 to generate 7,000 hours. So 30 for engineering and design hours. Every time the engineering and design time, sometimes we add another product and we have to spend a lot of engineering time to do the designing and fine tuning. So that means we'll be spending much more on engineering and design cost. And has it got anything to do with the volume? No, not at all. Right? It is just because how much of attention is required on this particular product. Material handling, what is the cost driver we have been given?
The weight in pounds.
Weight.
Yeah, weight. So it is whether because probably this is bulky material. So we have been told that it is the rate is 220,000 pounds. Pounds of material. So which means material handling cost is $1. Every time we handle the material, a kilo of material is moved to handle, it is
The
going to cost us.
quantity should be
$0.1.
Oh, it
220,000.
should be 220,000. Quantity
Yeah.
cost drive is 220.
Yes.
Correct.
That is right. Okay.
Point
0.1.
one.
And quality control, what is the cost driver?
That is inspection.
Number of
Number of
inspections.
inspections.
And we have
800 inspections.
inspection. So the cost driver is,
40.
and then the machinery related cost, how much?
45,000.
And the number of
machine
machine
hours.
hours calculated that it is related to the machine hours. So therefore the cost per cost driver is 50. So now this is what you've identified, right? So earlier we had, now again, if you go by this logic here, earlier we had a departmental rate. I think it was 14 in machining department and 6 in assembly department. Now we have 5 different activities. Each activity we have a different cost drivers. So this is what we have for each activity. So if we have 5 different activity cost poles and we know the cost per cost driver. Okay. Now, before we go any further, if you look at the question that has been given, that schedule, now what is your comment about the resource utilization on valve A and valve B?
Well,
Valve B on machine setups tends to be higher. Basically, except for material handling and machinery related cost, I think valve B takes bulk of the cost.
Exactly, right. So you can see it, right? Now, volume wise, if you take it, valve A is 30,000, valve B is only 5,000. But if you look at our schedule, machine setting up, 20 setups, only 20 setups for valve A, 100 setups are for valve B. 100 setups are for valve B. Right? So volume wise, it is 3,000 versus 5,000. But you can see most of the machine setup is for valve B and not for valve A. Okay, so what does it mean? Valve B is a specialty valve which we produce in small quantities and small runs. Valve A, because 5,000 units, you have to set up in 100 batches and you're going to produce that. But here, every time you set up, you produce more. Let's see. Okay, 30,000 divided by 20. Every time you set up the machinery, you produce 1,500 units. But here, every time you set up the machinery, you produce 50 units only. But the setting up cost is the same. So obviously, valve B seems to be more expensive. But it has nothing to do with the lesser number of units. Similarly, what happens with the engineering and design hours? We have been told valve A is only How many engineering and design hours?
1,000 hours.
1,000 hours. But valve B would require
6,000.
7,000. 6,000 hours. 6,000 hours. So which means it is not a proper comparison, but each unit of this would require on an average basis 0.03 hours engineering time only, but each unit of this would require more than 1 hour, right? So you need more attention to this product. It's more complicated product, more components, more finer product, and a newer product, and changes happening, uncertainties are more, so you need more management time. Material handling, of course, is the other way around. It's volume related. Here, 50,000. Again, each unit would require, each 170,000 divided by this, just to get an idea, right? Don't we are this is not an official calculation that we do, but we are going to get some insight. So each unit would require handling 5.6 kilos, but here each unit would require handling 10 kilos. It's a more bulky, more difficult to handle. Similarly, quality control inspections, I think it was 150 versus 650, which means 154, only 0.5% of the items are going to be tested. But here, inspection in terms of this. So you can, yeah. So, and here, you can see these are 13% of the items are going to be tested. Now, what do you see? Now, just the general idea is enough, right? I'm not trying to complicate you, but now you understand that. Now, now valve A is typically taking more resources than valve B is taking more resources than valve A, which has nothing to do with the volume of valve B produced, right? It's completely because it is more involved, more complicated, more finely quality control, more demanding product. So now when you try to calculate your overheads for these two products, we can do it quickly. Okay, you have to tell me what was you can look at your schedule and tell me what is the machine setting up cost per setup?
50.
Yes,
50.
machine setting up cost is 50. Valve A also, valve A and valve B both it is 50. Engineering and design time for valve A is how much?
30. Both.
Sorry. Rate,
No, the
sorry,
rate is 30.
Rate is 30.
30 for both.
For both.
It is.
Yeah.
Material handling cost
0.1.
0.1.
No, 0.1, not 0.
okay. Quality control cost
40.
40.
machine related cost
15.
15. So this is the information that we have. And okay, now we can see what is going to cost us to produce valve A and valve B. We can't calculate the per unit level. That will be a more complicated calculation. We calculate the total for valve A and divide it by the number of units. Now you have to tell me, out of the 120 setups, if you remember, valve A would consume only
120 setups.
20.
and valve B would consume
100.
100 setups. So therefore, that 6,000 cost base, 1,000 will have to be absorbed by valve A and 5,000 will be absorbed by valve B.
B.
Similarly, engineering and design time, valve A would consume how many hours?
1,000.
Only 1,000 hours. Valve B would consume
6,000.
6,000 hours. So therefore, this out of that 210,000 cost, only 30,000 will go to valve A, 180,000 will go to valve B. Material handling, valve A,
170,000 pounds.
170,000, whereas here it is
50,000.
5,000. So now this is more like a volume related one. We call this volume related because the material quantity, the weight is volume related. By the machine setting up, nothing to do with the volume, right? And engineering design, nothing to do with the volume. It is more to do with the complexity and the customer demand. Quality control also, how many inspections?
150 and 650.
150 for valve A and 650
600, yeah, 650.
valve B. So only 6,000 goes to valve A, 26,000 goes to valve B. Okay, right. And this machinery related cost, how many hours for valve A?
30,000.
30,000 for valve A and
15,000.
15,000 for valve B. So this is what you see. So even there, 5,000, 30,000 versus 5,000, but this is 450,000 versus 225. That much of disparity is not there. More than proportionately amount of hours are gone, right? So now when you do this, all together now you see, this is the total cost. How much? $504,000 is the overhead that should be absorbed by valve A. And when you add all this together, $441,000 is what you should be absorbed by valve B, right? And then when you do the calculation, valve A, we have 30,000 units. Valve B, we have 5,000 units. So therefore, overhead per unit will be 16.8 here on valve A and 88.5 valve B, right? This is basically 504 divided by 30. And here 441 divided by 5, which is 88.8. This is what we have. Which means 200 is the prime cost, 200 plus 16.8, 216.8 is the cost on valve A, and 200 plus 88.2, 288.2 is the cost for valve B. So this is what you see. Okay, this is going to cost us 216, and this is going to cost us 288, right? Got it? Now, I just put the activity-based rates also here, so then you can make a comment. 216.8 and 288.2. I have taken the value there itself. Right, so this is what you see. Now, what is your comment? Now, say this is what has been happening. If we did not consider the differences between the product 227, 227, both products seem to be having the same cost. But when we change it to the plant wide rate, still it appeared to be the same because both products have the same number of labor hours. So it didn't show us the difference. But then when you had departmental rate, we saw that this is a bit more cheaper, but this is a fairly more expensive. But now when you use the activity-based method, we say this is even more cheaper, but this is much more expensive. Okay, so this is the numerical differences. But what is the story tells us? Now, if you take this business, what is the impact that you think you will have on the business? Okay, before that, yes, Rajiv, what is the question?
No, what sort of occurred to me is, Kapil, if the product mix is not stable, for an instance, the product mix changes so that we sell more of B, in the first system, the recovery we will be under recovery.
Yes, exactly. The recovery will be under, yes. We will not be recovering the full cost. Basically, yeah, we will be subsidizing product B. Product A is going to be overburdened and product B is going to be subsidized. Anything else? Okay, when you look at the full context of the question, what we are looking at from the beginning, what we were told about the two products.
The second product was recently introduced. So some of the reasons that this engineering input and all that is high, because we may be still at the low end of the learning curve.
Yeah, exactly. Yes. That is, yeah, okay, yes. Now, if you take valve A and valve B, yes, valve A is an existing product which they have been producing for 15 years, but valve B is a new product, right? So therefore, obviously, it is going to be more costly. But then in terms of pricing, whether you're going to absorb that the learning curve into the client price is something else that you need to look at. But at least you know the true cost. It is going to cost you more in the short term, number one, right? So that is there. And apart from that, also we know that the valve A is a simpler product, right? Because it's a thinner fluids like milk. But valve B is a more complicated product. Right, thicker fluids, so it's a more complicated product. So obviously, simple product versus a complicated product. A simple product is something probably that can be done by anyone. There may be many suppliers probably, right? Not a rule, but there can be possibility of having more suppliers. And then at the same time, it's a simpler product means it may be more likely a more mass market product. More people may be using it. And then also it is more likely that it's going to be price sensitive. Right, simpler product that is used by more people, a greater demand. So it's more likely that it can be more sensitive to the pricing. Whereas product B is a more complicated product and very specialized product, new product, right? So therefore, obviously it can command a high price, right? And then what happens is, if we did not, like Raju also pointed out, if we did not differentiate that, if our cost model was not right, if our product costing model was not right, we would have been thinking of both products are going to be costing us the same. And let us say we had a 10% markup and sold the two products. And this is also going to be sold at 250. And this is also going to be sold at 250. But the point is that, and it is going to cost us only 217, right? So we are overpricing that product. And if the competitor has the right pricing equation, they may be selling far cheaper than your 252 price, because they know that the cost is going to be 207, and it's a price sensitive product, simple product. So therefore you can lose your market share on this product very easy. On the other hand, if you did not know this part of the story, thinking that, okay, your cost is 227, you assume that it's going to give you $50 price, $25 profit, just same as this, you're going to keep selling it, but your actual cost is 288. Right? Thinking that is 254, 352, whatever, you keep on selling it, but actual cost is 288. So it is far more costly. And sometimes you may be selling even below your cost, right? So, and your customers probably, if your competitors are having the right pricing equation, they may be selling it at a higher price, but you sell it cheaper, thinking that it is cheaper to produce. And then what's going to happen is more and more you keep selling happily, and the buyers also will keep on buying happily. But at the end of the day, you will start making losses, right? Without you knowing, you will be losing your money. So therefore, both things, the mass market, more simpler product, you may lose market share, and more complicated, more challenging product, you are underpricing, and then giving a super price. But while doing that, without you knowing, you may be losing your margins. You may be losing your margins. So that is what could happen is, and then at the same time, operational people may, realize that something is wrong, but unless you have the proper integration, it may not be revealed. So this is the story, how the costing model, no costing model is perfect. It's like a map. Right, the right costing model, the more accurate the costing model is, the better the information for decision making that you will be having, and the better the decision that you will be making. If not, of course, it can be detrimental to the operation. Any questions? Anything that you would want to share?
Not a question, Kapila, but occurred to me while going through this activity costing, activity-based costing. Basically, what we are doing is, in effect, converting all the indirect cost to behave like direct cost, because you have good information. So you can get them to behave at a, I mean, you have a unit rate. So it's basically, I'm not saying it will become a direct cost, but in effect, end of the day, the indirect cost started behaving like direct cost because you have good information.
Yeah, you have a better closely identified cost drivers.
Yes, yes.
Yeah, so you can plan, you can understand, and you can manage it better.
Yes.
Right. And then also now let us say now, just for an example, now even when it comes to preparing a budget, right? Even when it comes to preparing a budget, and let us say for the next period, you are doubling your volume from unit B volume from 5,000 to 10,000. Right? And you're changing unit A volume also by another certain number of units. And you may not be able to do a proper budget. If you put everything together, if you all adjust your budget cost based on the volume increase, right? You don't recognize the fact that there are lots of things, hidden costs that are there. And without you knowing, it will take a while for you to realize that, okay, your cost is going up disproportionately, but your volume is not going up that much. Why? Because there are complexities within the operation which are not recognized and which are not factored into. Okay, so therefore, your planning process also will not be right. You will not have the proper costing factor. Your pricing also will not be there. And then let us say you don't plan for that level. You only plan for mere 10% increase in volume, but that happens to come from valve B. If it happens to come from valve A, your cost may not be increasing that much. But if it happens to come from valve B, the cost may increase more than proportionately. So if you did not identify these cost drivers within the operation, so then you will have no clue of why your costs are going up. Because you may be thinking that, okay, my costs are going up, but the volume is not going up the same level. Why? Because you have not identified the real cost drivers within the operation. It's very important, therefore, you have some insight to this. Yes, Rajiv, you have a question.
So, Kapila, going through this, is it right to say in cases where product to product, the resource allocation is having a very stark difference from one to the other, it's better to go for ABC type of costing?
Definitely, yes. Definitely, when the resource utilization is different, you have to have more activity. It may not be a very comprehensive, fully fledged activity-based costing system, but you need to identify multiple cost drivers so that you have a better control and better insight and better control over what happens with your cost. And also more than that, your pricing will be more accurate actually. Okay. Anything else? Right. Now this discussion anyway, this product costing, activity-based costing and traditional overhead costing, this discussion will continue for another 1 or 2 lectures because we'll be going through some other dimensions of this equation. But for the time being, this is for you to give an absolutely basic idea of what happens in this product costing environment. And then depending on the choices that you make, the insight, the decision-making insight, and the information that you have, the quality of your information can drastically vary. Okay, right. I think we took a little bit of time more. If you have any critical question, we can get it clarified. If not, let's meet up next week. Anything specific?
Just a quick one. I think when you explained only, it occurred to me because of this activity-based approach, the step fixed cost related jumps are also captured into the costing process, right?
Yes, yes. To a certain extent, yes. Those step fixed costs, because it is due to other parameters. To a certain extent, yes, it is going to be captured.
Okay, that's it. Thank you.
Yeah. Okay, so we'll call it till there then.
Excuse me. How do I mean to how do identify which type of cost factors to be used to get the cost? I mean the unit rates or
Are you referring to the different activities? How many different activities?
No,
and
we
what-
actually in this particular case we talk about two types of cost factors. One is machine hours, other one is the item wise factors.
Okay.
So, yeah, which one will be more appropriate where to identify the cost factors?
Okay, so now actually now if it is that, say for example, that is we are taking departmental perspective, so then what we'll be looking at is we can somebody will have to spend a little time, not a lot of time, but say you look at the cost of the machining department and we see what are the components that makes up the cost of the machining department: machine depreciation, machine insurance, machine maintenance, machine operator cost, electricity cost, licensing, calibration, like that. There will be a lot of cost that will be there in the machining department. And then by looking at this cost, then the person, the operational people and finance people will be able to look at and see, okay, in this department, based on this cost structure, like the space may be not very huge because not a lot of people, there's a one expensive big machine. One machine may not be even a big machine, which is in a very small location, right? And since it is expensive, your machine cost will be higher, space cost will be lower, insurance cost will be higher, operator cost may be higher, like that. So then you will have one set of cost structure. Whereas another department, there are a lot of people who will be doing manual assemble work. When you look at that, you may see not a lot of machinery, lot of people, their salaries, their whatever, the overtime incentives and things like that, and the space cost is more, the tool cost may be less. So like that, you need to, operational people and the finance people will have to sit together and then take a look at and understand what drives cost in the respective department. So that is the thing. So by operational understanding only, you can identify what is the cost driver. That is if you go take a departmental view. But even if you go through the activity-based scenario, probably the internally you may not be able to do it, but someone who has a more clearer idea of how this is going to be happen will do some sort of formal activity, formal whatever the facilitation, to see what people actually do and what resources are actually more consumed. Some sort of a formal structured interviews, discussions and analysis will have to be carried out if it is activity-based costing. Did I answer your question?
Yeah, okay, thank you.
Okay, right. I think so. We took time till about 2:45. You also must be hungry. I'm also a bit hungry. So shall we? Then I'll stop sharing this.
Thank you.
Right. Okay, so we'll wind up with that then. Thank you. So I'll, if you feel that this is useful, the same changed one, I'll ask them to share it with you after the lecture immediately. I'll ask Nipunika to share. Okay then.
Okay.
Right.